Okay, welcome everyone. Welcome alumni and friends to this 2022 Alumni Weekend Dean's Lecture. We're really happy that you could join us today for this special occasion, and it's really nice that we can finally do this in person. I would like to start by acknowledging that we work and live on the territory of the neutral Anishinaabe and Audenosaunee peoples. The University of Waterloo is situated on the Alderman Tract, which is the land that was promised to the Six Nations, and that includes 6 miles on each side of the Grand River. So this acknowledgement is the first step toward reconciliation, and our Office of Indigenous Relations at the university is actively working to guide us toward what are the important next steps. So my name is Christiane Lemieux. I'm the Associate Dean Operations and Academic for the Faculty of Mathematics. So that's kind of a long and formal title that essentially means I'm the Vice Dean of the Math faculty. And I'm also a professor in the Department of Statistics and Actuarial Science. So we have a lot of exciting events for you today, starting with our Dean's Lecture that will be delivered by Professor Maura R. Grossman on the use of responsible technology. Then we have self-guided tours in our mathematics buildings. And later this afternoon, we have the celebration for the 20th anniversary of the double degree program between the math faculty and the business school at Wilfrid Laurier University. So first of all, I'm not as used to give this kind of address. I'm more used to give research talks or to teach, so I hope you will forgive me if I have to look at my notes every once in a while. And I would like to start by just talking a little bit about the Faculty of Math and giving a bit of our vision for the future. So of course, the last 2 years have been challenging for us, as I'm sure it has been for all of you. We had to really reimagine ourselves and figure out how do we do research, how do we educate, how do we connect with our community in the context of the COVID pandemic. And in some sense, the math faculty was built for challenges like this because the faculty was built on principles of creativity and thinking outside the box, and certainly we've seen a lot of this resilience and ingenuity come out during the last 2 years. And just to give you some examples, our researchers were able to very quickly adapt and start doing research on COVID-19, whether it's in the form of predicting the spread of the disease or using AI to help with the backlogs of elective surgeries in hospitals. And then our instructors had to pivot to online teaching, and they were able to do it while maintaining the high standards that we are known for. And our outreach groups were also able to really make an impact in the community because even before the pandemic, they had already developed, I'm thinking here about the CMC, or Center for Education in Mathematics and Computing. So they had already developed all these online tools and modules to help high school students with math and computing. And that proved to be extremely useful to those students who all of a sudden had to learn these topics from home and were not able to be in the classroom. So their website that has these tools has seen an increase of 200% in the last 2 years in terms of usage, and this is all free and available to anyone in the world. And I have to say that I've also been really impressed by our students and how they were able to adapt and be resilient and go from one mode of learning to the other, and also have to do their co-op term online, sometimes in their apartment or their dorm room instead of being physically with their employer. And now they're back on campus with the same enthusiasm and motivation, which is always very energizing to us. So with all of that, I think it's fair to say, or we can be hopeful that we're going to come out of this pandemic even stronger than we were before and ready to tackle big challenges. So what are these challenges? Well, there are many of them, but the one that we're going to focus on today and that ties in with our Dean's lecture is the responsible and effective use of data. So, of course, as you might know, we are in this era of big data. By some accounts, there's about 2.5 quintillion bytes of data being generated every day in the world. A quintillion is 10 to the 18. It is a big number, so it really makes sense to talk about big data. And of course, data can be super useful, and we've seen this if we just think about healthcare and thinking about the pandemic. Data has been useful to identify new variants or, determine how to organize massive public health initiatives, how to identify new treatments, how to predict the spread, and so on. Data can also be useful for climate change to help us predict extreme weather events or determine how an ecosystem might change in the future. But really, there's the way this era of big data is impacting every sphere of human activity. So we can think of data being used to construct smart cities or just to drive economic growth and so on. So this is a quote from one of our faculty members, Professor Chris Spock from the Department of Applied Math, who had this to say about the transformative impact of big data. So he said, big data has been compared to the invention of the microscope several centuries ago, which completely opened up a new world of microbiology. We now have enormous amounts of data that we can analyze and learn something about human behavioral patterns and how they respond to their environment. But we need mathematics to help us interpret what's happening. And of course, with this big data, it's exciting to think about everything that we could do with it, but we're still at the very early stages of the data revolution. And our ability to effectively clean, mine, and interpret data is still lagging behind our ability to generate data. And also, this era of big data is opening a lot of new questions and ethical challenges. So some of the questions we have to ask ourselves is, how is data used? Like, who owns the data? How do our biases and assumptions are reflected in data sets? And how can we make sure that we use data responsibly, which again is going to be the topic of our Dean's lecture today. And in one of the most notorious examples of data not being used in a good way, and it's actually something that I think Maura has talked about in other venues, there was a case or a study done by researchers from MIT and Stanford who were able to see that a certain face recognition AI software was such that for light-skinned men, it was very good at predicting or detecting gender, like the error rate was 0.8%, but then for dark-skinned women, the error rate was as high as 34%. And you have to think that an error rate of 50% would be like, you might as well just flip a coin. So 34% is a pretty bad error rate. Of course, the reason why something like that happened was because the data sets that were used to train the algorithms that were used in this face recognition software were biased. They were not representative of the population, and the people behind the software were not able or didn't realize that there was this issue with their data sets. So it's clear that if we cannot identify and address these issues, then the real-world benefits of the data revolution will be very limited. Now, in terms of the Waterloo's and the Faculty of Math's leadership in data science, we can really play a very big role. We think we're ideally positioned to realize the full potential of the big data age by both overcoming technical challenges, but also addressing ethical concerns. And in particular, the Faculty of Math is uniquely positioned to deal with data science because we bring together the three disciplines that are needed for data science, so that is computer science, statistics, and mathematics. We're also the only dedicated Faculty of Math in North America. So here's a place where the collisions between people from these different fields are happening a lot more often than elsewhere, especially because of also how big we are. And the expertise we have in these fields are really world-leading strengths. So just to give you a little bit of data, some of the national and international rankings are putting both computer science and math in the first place in Canada by Maclean's, and then the QS rankings, which is an international ranking, at computer science 25 in the world and math 41 in the world. And so with all this breadth and depth of talent and expertise, we have people working really at all stages of the data pipeline, so from data management to security and privacy, and to modeling and analysis. And of course, Waterloo is also home to a very rich entrepreneurial ecosystem that has given rise to over 500 startups. So we're well equipped to translate these data science breakthroughs into ventures that can change the world. And finally, we're also uniquely attuned to the ethical dimension of technology use. So here in the math faculty, we're not just interested in advancing technology for the sake of technology, but we also always ask, to what end? And a really important key to be able to do that is diversity. And so we are working proactively to make sure that our faculty is diverse, because if our student and faculty bodies are composed of people that represent all racial and gender identities, we're much less likely to make the kind of mistakes that we talked about and to build these biases in technology. So I want to talk about some of the initiatives that we're doing to promote diversity. So first, we have these two long-standing groups in the faculty, so Women in Math, or WIM, and Women in Computer Science, or WICS. So both of these groups are supporting and encouraging women and underrepresented groups who are studying math and who are thinking about careers in math and computer science. And they do that by creating a supporting environment for these groups, but also they work on making sure that young women can see math and computer science as options for something they could study in university. They are also working with external stakeholders and bringing initiatives to the faculty, again, to support these groups. And both groups strive for all genders to be well represented in math and computer science, so including trans, gender fluid, genderqueer, and non-binary. There's also the Waterloo Women Impact Network, or WIN, which builds on the work of WIM and WIX by engaging the university's external community of alumni, friends, and partners. And over its first 2 years, WIN has connected thousands of allies in virtual webinars that had themes like women in entrepreneurship, workplace sustainability, and the social, economic, cultural, and political achievements of women. They've also raised money for programming and scholarships to help students and faculty in the math faculty, and they've had about 77 donors that made 150 gifts for a total of slightly over $40,000. And I will provide more information at the end in case you're interested to learn more and even to join this network. The CEMC, which I mentioned before, so our Center for Education in Math and Computing, is also committed to diversity and inclusion. They're working hard on ensuring that more women are interested in entering the STEM fields. And so since 2002, they had over 2,000 students who have participated in CMC events that are designed to spark interest in math and computer science for young women and as well as trans and non-binary youth. And just in 2019, they had over 120 students who participated to something called Think About Math. So that's a day-long program that brings secondary school girls and trans and non-binary teens together to challenge stereotypes and explore how math can make a difference in their lives. And the CMC is also working actively to try to reach communities where enrichment activities in math and computer science are very scarce or maybe not present at all. We've also introduced some scholarship for underrepresented groups. So one of them is the Rico Mariani Scholarship for Black and Indigenous students in computer science. But we also recognize that there is still work to do. Our faculty is not immune from racism and sexism, both systemic and overt, and the negative impact of racist and sexist structures. So for this reason, we're committed to take action to do better through student, faculty, and staff support and engagement, and by collecting data and doing surveys, and also by doing better consultation of our external stakeholders and community. We really think that this commitment to diversity, inclusion, and the responsible use of technology is key to our ability to be leaders in the data revolution. And as we look to the future, we're seeking to build on our many strengths in data science. We think that with the breadth and depth of talent and expertise we have in the faculty, we have an obligation to enrich our ecosystem and create the data solution that the world so desperately needs. So that was a little bit about the Faculty of Math and our vision for the future, and I encourage you to get in touch with us and share your feedback. And now it's my great pleasure to introduce our featured speaker for this morning. So Maura R. Grossman is a research professor in the David R. Cheriton School of Computer Science at the University of Waterloo. She's also an adjunct professor at the Osgood Hall Law School of York University and an affiliate faculty member of the Vector Institute for Artificial Intelligence. She's also principal at Maura Grossman Law, an e-discovery law and consulting firm in Buffalo, New York. Maura is most well known for her scholarly work on technology-assisted review, or TAR. Most notably, her work entitled Technology-Assisted Review in E-Discovery Can Be More Effective and More Efficient Than Exhaustive Manual Review, published in the Richmond Journal of Law and Technology in 2011, which has been widely cited in case law, both in the US and abroad. She's also known for her appointments as a special master in multiple high-profile federal and state court cases. And in addition to her JD from the Georgetown University Law Center, she also holds MA and PhD degrees in psychology from the Derner Institute of Adelphi University. So Professor Grossman will talk to us about how a clinical psychologist and lawyer ended up as a research professor in a school of computer science, and explain our mission to teach data science, computer science, and software engineering students to move slower and break fewer things. So, Maura, the floor is yours.
Thank you. Good morning. Absolutely delighted to be here to talk to you about my mission, which is a little bit different than some of my colleagues. So first, let me tell you a little about me. That's me, and that's me. There are different me's at different times. I started out as a clinical psychologist. I did that for roughly 10 years. We'd need a lot more alcohol for me to explain how I got from being a clinical psychologist to being a lawyer. But suffice to say, my personality was less, tell me about that, and okay, what do you think you should do, versus, okay, time to grow up, here's what you got to do. And the first one is more the psychologist, the second is more the lawyer, so I made a better lawyer. When I was a lawyer, I was faced with the problem. I worked at a very large, prominent Wall Street firm in New York, where we were swimming in data. And so I would work on litigation, legal cases, where we'd have millions and millions of documents, but we'd have 3 lawyers and 20 million documents. And how do you find the evidence in a vat of data that size? Well, what the firm was doing was having baby lawyers look through the stuff one by one by one. But as the data sets got larger and larger, that became almost impossible to do, to look at 20 million documents. So my firm said, you got to solve this problem for us. And I said, there has to be a technical solution. I just don't know what it is yet. So I started going to computer science conferences and information retrieval conferences. And I actually met a professor at the University of Waterloo, just by coincidence, at a conference in Maryland. And he was one of the top spam gurus in the world. And the light went off in my head. Spam, not spam. Relevant evidence, not relevant evidence. Maybe his spam filter could help me with this problem. Maybe we could tweak it. So we started to work together and started to write papers. And we were the first to show in 2011 in the paper Christiane mentioned that these algorithms, supervised machine learning algorithms, could actually beat lawyers, more efficient, 50 times more efficient, and more effective at finding the evidence in a case. My background as a psychologist helped because I knew how to do research, I knew statistics, and so we were able to design studies to start to show people this, and eventually the courts adopted it, and it has changed the whole way litigation is done, at least in the United States and all around the world. So I got more and more interested in using supervised machine learning to solve real-world problems. And so that's how I got to Waterloo, in addition to marrying the guy with the spam filter. So I get here, and I got to figure out what I'm going to do with myself, which I'll talk about. But I became director of women in computer science for 18 months when Joe Attlee was on leave and sabbatical. And I ended up getting a fellowship that brought me back to doing research in health. And I have, over time, become a huge advocate for EDI and anti-racism initiatives. So this will give you a little background to understand how I got to where I am. So when I came here, my research field was called high recall information retrieval, which essentially is finding substantially all of something with the least possible effort, and being in a position to be able to prove that, because it's a very high-stakes situation if you don't. So law was obviously one of the first, and government records, where they have to make records public, was another area I did work in. More recently, because of my fellowship, I helped the World Health Organization find every study in the world, or in most parts of the world, that had been written on COVID-19, so that they could do a systematic review of them. I'm now working with them on Ebola research, so, and so on, lots of other uses. So I got here, and I was, in some ways, sort of a spousal hire, but so I had to find a job for myself. And I noticed, like, why doesn't anybody at Waterloo talk about computer science and? They just talk about computer science. They talk about optimization. I hear this word a lot. But I don't hear, like, law, health, social good. You know, yes, there was CFM and some other collaborative stuff. But so my first semester, I did a very traditional high-stakes information retrieval graduate seminar with he was my fiance at the time. And, you know, your typical read every week, a publication, have a student present the publication, discuss the publication, and do a project at the end. But I had 3 surprising discoveries. 1, students were really interested in law. 2, they were really, really interested in getting feedback on their presentations. And so Gordon would give, you know, sort of substantive feedback, and then they would turn to me and they really want, like, how was my presentation? Like, can you know, so that was interesting. And I encountered the first woman student, she was the only woman in the class, who really, it troubled her. And she would have panic attacks before class, and she would call me before class, and I'd have to talk her through coming, and that it was okay. She was the only woman. So that was my first encounter with some EDI kinds of issues. So I decide I got to do something interdisciplinary and sort of poke people here. So I look around, but there's no law school. There's a legal studies department, but there's no law school. So that wasn't going to work. So I decided maybe I'll find an outside law school and do a course pulling together graduate computer science students and law students and bring them together in the same room. So I approached a bunch of law schools, and I finally partnered with Osgoode Hall, which is one of the top law schools in Toronto. And I did designed a course called Artificial Intelligence, Law, Ethics, and Policy. And from what I understand, it was the first of its type, where we actually brought together 2 disciplines from 2 different schools to talk about issues. So we started with what's technically feasible, because for law students, this is all magic. They just have no idea how anything works. And then for the computer scientists, well, what are the issues that what you're doing raises? So for example, if you design something that uses a fingerprint to unlock it, that you can be forced to give your fingerprint. But if you design something that requires a password to unlock it, you cannot be forced to give your password, because one is testimonial and the other isn't. And so understanding something about the law helps in design. And the requirements for the course were 20% participation. You could participate in Slack or in class. All of my courses, attendance is required. I don't have any courses where people can just read a book and not show up. And we gave weekly papers. They had to do 8 out of 10. And an interdisciplinary project where 2 lawyers worked with 2 computer scientists to build something. No papers. Topics, well, lots of stuff. Obviously we started with definitions. We talked about whether systems should ever have rights and responsibilities. We talked about relationships between robots and humans. What do you do when something goes wrong? Who's liable? Military uses, autonomous vehicles. We talked about all kinds of biases in both directions, both in favor of technology and opposed to technology. And value of transparency and explainability. So are there areas, so we may know that, for example, that deep learning works better than, or is highly accurate. But what happens if it's an application that's are there applications that are so important, like taking somebody's freedom away, that it's not okay, even though the algorithm is accurate, that there is some value in transparency. We talked about that. We talked about unemployment, technological unemployment, and what that means, for example, what autonomous vehicles means for truckers, and so forth. Regulation. This is not, okay. So here's what I found. This is how the computer scientists came into class. Techno-solutionists. Computer science, technology, AI, the answer to everything, right? And this is what the lawyers came to class. It's all bad, can't understand it, can't use it, it's dangerous, and we worked to come somewhere in the middle. My goal was for the technologists to understand more of the challenges and the issues, and that they really needed to think about what they were doing and building and what the who wins and who loses. And the lawyers needed to understand the technology because their solutions, like get rid of intellectual property, they were such blunt instruments. And these people are going to grow up to be regulators, and if they have no understanding whatsoever of the technology and how the technology works, they cannot possibly be effective as regulators and as lawyers. So challenges. How do you connect classrooms at two different universities? Firstly, CS had no room that had the equipment I needed. Engineering did, but that room was very, very busy. I found a basement in MC that was used as a training room that happened to have the equipment that I needed that matched the equipment in a boardroom at the law school that was only used for board meetings and other, really important stuff. They're on completely different calendars. It never occurred to me until I was well along that they had semesters, we had trimesters, and the dates didn't match up. So for some extra filler for 2 classes, one here and one there, I showed an episode of Black Mirror and had people look for the ethical issues in that, and so that took care of the classes that didn't match. One was graded with numbers, one was graded with letters. I had to figure out how I was going to do my curve. How do you get the damn technology to work? It never worked. It never worked right. So I'm collecting 2 rooms, and I'm waving, and they're saying, so that was really a challenge because it was well before the pandemic. Now we know how to do all this stuff, this video stuff. We didn't in 2016. Nobody was doing it. And so that was really challenging, and to try to keep the students from getting very, very frustrated when they're on the screen and they can't be heard, or they're teeny little dots and I don't know people's names because I can't see them clearly enough. And how do you avoid the second-class citizen problem, which is, I'm sitting here at Waterloo, I'm with a group of students, I'm paying attention to them, and we all forget that there are 15 other people sitting in a room somewhere else. So my second year, I went back and forth every other week. But there was still a little bit of a second-class citizen problem. People would talk more wherever I was. So, challenge. Rewards, the students loved the course. At Osgood, it was labeled one of the top courses for the year, and students felt challenged and felt that they had really gotten something out of it, so that was good. So the pandemic hits. We have a new program in data science, a master's program in data science. And we decide it's important that this data science program have an ethical component, so who are you going to ask? So I said, sure, happy to do it. But there was an appetite to create a whole course for that. So we decided we would do a series of workshops. And they would be 3-4 hours, and 3 of them. And I found, first thing, very challenging, very hard to be interesting for 4 hours. Very hard to get anybody to sit through 4 hours. So I had to involve my TAs in some of the teaching just to change the pace during the course of class. It was a required milestone, and it was pass-fail. So how do you get students to care? All they want to do is finish this, check it off. So that was a real challenge, and I think over time, the students started to see that this really mattered, that this actually was important stuff to learn. And oddly enough, moving online improved things. When I lectured or spoke in a room like this, people would have their computer or laptops open, and they'd be online doing whatever they were doing. And I didn't have nameplates, and I couldn't remember all of the names, so it was hard to call on people. But it was great in Zoom because their name was right there, and they weren't doing other things. So we actually found that students talked more and found it safer to talk about ethical issues from a screen rather than in a room. And then we could also use creative stuff, like put them in little breakout rooms, Zoom breakout rooms. We could use polls and do all kinds of things we couldn't do live. So I wondered, you think this will work with undergrads? Because we have so few grads. I mean, I really want to have impact lower on, because lots of our undergrads move on, and they don't take graduate degrees. So I had an opportunity to check this out, because CS 492, which is Social Implications of Computing, is a course that's routinely taught here. And Robin Cohn, who usually teaches it, was taking a sabbatical and asked me to cover 2 sections for her. And so I said, ooh, I'm going to tweak my little thing and see if it'll work with undergrads. So I did. Same sorts of topics, but sort of restructured it to sort of match that course. Robin did her course 2 days a week. 1 hour was readings and discussion. The other hour was sort of role-playing debates. That wasn't so much me, so I decided to do 1 2-hour class and just have discussions, but covered the same sorts of topics that I had covered in my grad course, including bias and big data and all that stuff. And it went pretty well. The students seemed to like it. And so I'm trying to find, and what am I going to do next? What's my next act? And the George Floyd incident happens. And I decide it's not good enough for me just to be a nice white ally. I actually need to do something more. So I decided I want to teach a whole course on discrimination in computing. And I'm a white woman, so I figured I need to do this with somebody. So I looked around, and there is a black professor in history. He's now an associate vice president, Christopher Taylor, who I saw had done an online program that I took with anti-racism training. And I said, I'm in love with this guy. So I'm a groupie. I reach out to him and I say, do you want to teach this course with me? And he said, sure. But then he got promoted and all kinds of stuff. So I decided that there needs to be diverse instructors. So I look around in CS, and we aren't doing as well as we could. We need to be doing a little bit better. But I found a queer professor who was interested in co-teaching this with me. So we had our diverse instructors. So we had to decide, do we do this online or back in person, because the campus was starting to open. We started the semester online, and we decided to keep it online for the very reason that I said before, is the students actually found it easier to talk about personal experiences of racism and discrimination by the safety of being in their own home, being able to write something in the chat rather than say it out loud. So we kept it online. We also had a lot of very diverse guest speakers from all over the place, and it was much easier to deal with that online. One of the harder challenges is, how do you create an environment where you say to people, you are free to voice any opinion you want to voice. For example, I hate these stupid diversity programs that Google and all these places have because they're not fair to me as a white man anymore. It's harder for me to get a job. You want people to be able to talk about their feelings about that stuff. But what happens when somebody says something stupid? Like, women, somebody said this in class, women want the lower paying jobs. They don't really want high pressure, jobs, so it's okay, or somebody says something racist. And so you want to teach people and you want to push back, but you don't want them to feel like you're criticizing them or that they're a bad person, because that is the worst way to try to get somebody's ear flaps up. So we struggled with that because we did say at the beginning, you can disagree with people, you can tell them something they've said hurts you or upsets you, whatever. You can't call them racist, sexist, whatever. You can't label them. And it was hard reaching that balance, and I'll show you some of the feedback we got. Decolonizing the syllabus was challenging because almost everything's written in English is sort of Western. And we worked really, really hard to try to have a syllabus that had broad representation of authors and researchers. And we included a weekly From the News where we allowed students to pick a topic that we would talk about so that they could have some participation in the syllabus. We thought it was going to be a challenge to fill 2 sections. We did. We had 25 to 30 in 2 sections, which was actually a pretty good number. We were willing to take a few more, but that turned out to be a good number. And the biggest question is, can we have any impact? Can we get anybody to stop and think about what it is they're doing? Or is it, you ask everybody, you get everybody to talk and they'll say how horrible Facebook is and breaches of privacy, and then you ask them, tell the truth in a poll, an anonymous poll, how many of you would take a job at Facebook if you were offered? And then virtually the whole class says yes. So can we have any impact on this? So the course considered the ways in which computing systems enable, encourage, or prevent discrimination of all types. Again, and also looked at technical and social solutions. Synchronous, must attend, must participate, 20% of the grade. We also had a Slack channel. Short bi-weekly papers, some of which were technical prompts, like how would you fix this problem? And some of them were more thoughtful and personal prompts, like pick a disability and now go through your whole day with that disability, and what technical challenges did you encounter and what would you do about them? And then they had to build something. Again, no papers. Had to build something for the course. So here are some of the topics. We did lots of case studies. There's so many out there. From priests being outed on gay priests being outed on Grindr and the use of data and tracking to find these people. We're going to find this also. It's starting with the abortion in the United States, all kinds of tracking of people to see, what they're doing with their bodies and so forth. We looked at high-tech redlining, bias in lending, racial discrimination in the criminal justice system, facial recognition, predictive policing, disparate impact in healthcare for minorities, particularly when algorithms are used to make health decisions, First Nations internet access, or lack of it is a better word. How do you search the internet when the language you speak is not represented anywhere on the internet? We talked about gender discrimination, violence against women online, which is just really a problem. We talked about big data, right to privacy, right to be forgotten. We had a person come in, a trans woman who had been a sex worker, had done pornography, and some of the photographs were on the internet, and how that impacts your not understanding as a younger person what kind of impact that was going to have for the rest of your life, and how do you get that information off the internet. We talked about sexual orientation and gender identity, disabled people, government surveillance, data colonization. Very interesting, we found articles where people in China actually like the Chinese credit scores, even though Western view is very, very negative about the scores. That's not necessarily the perception in China. And then we talked about potential fixes. So overall score for the course was 4.5 out of 5 for both sections. Considerably higher on many of the individual questions, except for workload and grading, which is almost always the case. We had heavy reading, heavy reading, and the students thought the reading was heavy. But if you see some of the responses, yes, we obviously had some impact, expanded my viewpoint not only about various issues that exist, but also how different people are affected in various ways by these issues. In addition, I realized the role I play directly and indirectly in propagating or solving these issues. So we did have the kind of impact we had hoped to have on people in terms of move slower, break less things. Challenges. Other positive outcomes, we did have a big showcase, public showcase of the students' projects. Some of them were amazing, like one group did research on avatars and how diverse avatars are, and in various systems, how flexible building an avatar were. So for example, if you needed a head dress of a certain kind, could you find it on various tools? But they also built something for white people that had if you tried to find hair like yours, you couldn't find hair like yours, you couldn't find glasses like yours. And so that white people could have the experience of trying to build an avatar that looked like them and not having options that resembled anything like themselves. We have 3 publications working with our students on some of their projects, and I got the benefit of a URA both for the spring and the fall. 2 challenges. Can a course in discrimination actually discriminate? And the first was a student who said, you let too many yes, we understand why you wanted unpopular opinions to be voiced, but you should have told them they're bad. And that was really a struggle for us, of knowing how much to push back when somebody says something that is maybe problematic. And sometimes the students wished we had shut these people down rather than letting them speak, but we felt that it was very important to let everybody speak their mind and to try to help them see other positions rather than saying you're wrong or stepping in. But maybe we have to step in more because some students felt that that was hurtful to them. The other thing that was even more of a challenge is that the lowest 10 grades in the class were obtained by non-native English speakers. And we got lots of feedback from non-native English speakers that the course put a premium on orally and in writing being able to express your views on these issues, and that in some way we may have inadvertently penalized non-native English speakers. And so they said, gee, we wish you could figure out how to make this course a little more open or available or inclusive of non-native English speakers. So what we may do for next year is have a certain % of the grade that the student can decide, should it be oral, should it be written, or should it go towards my final project, so that they can decide what they do well and how to allocate the grades instead of ours saying, 35%, 40%, so on. So that's the mission I'm on, and I don't plan to stop anytime soon. And I think I had some impact on some of my colleagues. Some of them are doing interdisciplinary courses. We had a course this semester on software engineering on anti-discrimination. So I'm really excited about this. I think it's an area where we can really lead the way in getting our students, not just, they already are spectacular at building things, but having them build good things. So thank you.
Thank you very much, Maura. It was really fascinating presentation. Maybe I'll just ask a question and then see if anyone, I should remove this, anyone has a question. So in terms of getting these courses to undergraduate students, do you know if employers are already at the stage where they really want to see this kind of training in our students? Are we ahead of the game? Are we following? Where is that sitting in terms of what the employers are looking for?
I think it varies. A lot of the employers, at least on paper, say they want students with these skills. It's harder when they actually come in and they start speaking up, and it's going to get in the way of shipping something or getting it done. One of the things we talked about is when you see these issues, flag them as early in the development process as humanly possible, because once something's about to ship, to be able to get it to stop and fix is very, very hard. So I think people, the employers appreciate, at least my students who are at COP now are saying that they are raising these issues with their teams, and they have received receptivity to, but it has to be early enough in the process. Yeah. Otherwise, people say, well, on the next version, or something like that.
Great. Are there questions from the audience? Yes, go ahead.
Yeah, you mentioned at one point in this talk that you asked yourself the question of whether Waterloo can be interdisciplinary or not, and you have an interdisciplinary background. Do you think it's more than Waterloo can be doing to become even more interdisciplinary, and what would you suggest Waterloo does?
I think it's very challenging the way the university is structured with all these silos, faculty of math. It's very challenging on campus to do interdisciplinary stuff. I couldn't even find a room that had technology that I needed within the school. We could be doing more. I think there is going to be a movement. My understanding is that the university is looking to set up some more interdisciplinary and crossover, because right now the structure makes it very difficult. If you wanted to do something like with this professor in history, who gets the credit for it? Who pays for it? How many students from which department? And we have to work through all these issues. I'm hopeful, given that the provost has expressed a commitment that there'll be more of this. But the people like me, they're such a small handful, and even somebody like me, probably if I hadn't been getting married to a professor in computer science, if I had applied to the School of Computer Science with my credentials, I doubt I would have gotten a position. Now that I'm here, people see what I could do in data science and so forth. But I'm hopeful that there's the foresight about how important it is for people to have more than one skill set. Thank you.
Yes, go ahead.
So I know we've been talking about that for the AI Institute to take the lead in offering some kind of responsible technology offering that anybody on campus would be able to take. I know when I taught the graduate seminar on AI, I did get requests from people all over campus to take it. The problem is then there are all these rules about pecking order and who can come in and whatever, but I do agree. And there are a few others. I know there are a couple of other courses on campus in other departments. In philosophy has one, for example, on ethics, in technology. The difference for me is I actually have some technical background. Often these courses are taught by people like a philosopher probably doesn't know machine learning in the way that I understand it. So, but I agree with you. I think probably just about everybody needs to take a course like this. And I think the AI Institute is aware of that and talking about how that can be done.
Thank you. Are there other questions? Well, if not, thanks again so much, Maura, for your presentation. It was really interesting. And I just want to close by thanking you so much for coming today. It was really nice to be in person. And I want to really express the faculty's deep appreciation for you, our alumni. You're really central to everything we do. By being outstanding ambassadors for the Faculty of Math brand, you really help us increase our prominence worldwide. By giving us your wisdom and advice, like you just did now, you can really shape our future and make sure that we continue to be successful. And by hiring our co-op students and giving them opportunities for these educational experience, you help shape our future leaders. And finally, with your generous gifts, you make sure that our students and our researchers are able to take risks that can really help them solve big problems. So thank you so much. The slide there is just giving you some contact info in case you're interested in some of the things I mentioned. And again, I just want to repeat that there are other things planned today. We have self-guided tour. In particular, if you haven't seen it, we have the Stairway of Constance that maybe wasn't here when you were on campus. So in MC, there's a kind of interesting stairway that you can go check out. And then later today at 3:30, we have our cocktail reception for the double degree, the 20th celebration, 20th anniversary, and there will be a guest lecture as well. So thanks again for coming.